This is solving equations using multiplication or division. Whenever we're solving equations, our goal is to find the value of our variable. We do that by isolating the variable or getting the variable by itself. The first step when we're solving an equation should be to find the equal sign and split the equation into two parts at the equal sign. Now, this multiplication property of equality says that it's okay to multiply one side of my equation by a number as long as I multiply the other side of the equation by the same number. That will keep things equal. So when I'm trying to find the value of my variable here, which is x, I see that x is not alone. Right now it's x divided by 4. So I need to get rid of the divided by 4. The opposite of dividing by 4 is multiplying by 4. Division and multiplication are what we call inverse operations. They undo each other. So I'm going to multiply by 4 here so that my dividing and multiplying by 4 will cancel out and I'll be left with x. I can do that as long as I also multiply this side of the equation by 4. And 2 times 4 is going to give us 8. Every time that I solve an equation, I also want to make sure that I check my answer. So in order to check my answer here, I'm going to plug this 8 back in for my variable. Instead of writing x divided by 4, I'm now going to write 8 divided by 4. And I'm actually going to solve 8 divided by 4. And I get 2. Both sides are 2, so my answer checks out. Let's try another one. In this equation, I have w divided by 3. I have a division bar here. It's exactly the same meaning as the division sign I see here. It's just written differently. So you may see it written like this or like this. So I have w divided by 3 equals 12. I want to solve for w, but right now I also have a divide by 3 over here. To get rid of the divide by 3, I'm going to do the opposite. I'm going to multiply by 3. Whatever I do on this side, I also have to do over here. I want to show that with my work. Here, multiplying and dividing by 3 cancel out, and I'm left with w. And over here, 12 times 3 gives me 36. Then I'm going to briefly check my work. So when I go to check, this number is going to get plugged in for w. So I now have 36 divided by 3. I can even try that on a calculator. It gives me 12. Both sides here are 12, so my answer checks out. All right, we're going to look at another example. This one uses the multiplication inverse property, which basically says whenever I'm multiplying by a fraction and I want to get rid of that fraction in order to isolate my variable, I'm going to multiply by that fraction's reciprocal, okay? So in this first problem, I have 1/2 x equals 4. To start off, I'm going to split my equation at the equal sign. I'm solving for x here, and I see I have 1/2 x. So to get rid of the 1/2, I'm going to multiply by its reciprocal, which is 2 over 1. Okay, and those will cancel out. For those of you who remember cross-reducing, my 2's would cancel out and both become 1's, and I'd end up with 1 times 1 on top and 1 times 1 on the bottom, and 1x is the same as x. So basically, when I see a number and I'm multiplying by its reciprocal, it's going to cancel out. I have to do the same thing on this side, though. I have to multiply by the reciprocal, which I'm sorry would be 2 over 1. So in order to do this, I'm going to put a 1 under this guy also. 4 times 2 is 8. 1 times 1 is 1. And 8 over 1 equals 8. Then I'm going to check my answer. I always want to check it. So I got 8 as my answer. I'm going to put that back into the original equation. So I had 1/2 times 8 equals 4. Well, 1/2 of 8 is 4. 4 equals 4. It checks out. All right, let's try a more complicated one. I'm going to split it at the equal sign. To get rid of a fraction, I multiply by its reciprocal. So I'm going to multiply by 7 over 2. And I have to do that on both sides. So here it's going to cancel out, and I'm left with x. That's the easy side. On this side, I'm going to put a 1 under my 6 here. 6 times 7 is 42. 1 times 2 is 2. And 2 goes into 42. 21 times exactly. Another way that I could do this problem is I could do some cross reducing. So when I'm doing my problem right here, I might see, oh, 6 and 2, I can cross reduce. I can divide them both by 2. 3 times 7 is now 21. 1 times 1 is 1. And I go to right to 21. So either way works. I want to check my answer before I leave this problem. So in order to check, I'm going to plug this guy into my original problem. So I had 2/7 times x would be 21. I'm going to make it 21 over 1. And I want to get an answer of 6. So I'm going to cross reduce my 7's here. 2 times 3 is 6. 1 times 1 is 1. 6 over 1 is the same as 6. So my answer checks out. This next property says that I can divide an equation by a number as long as I do that to both sides. So once again, in solving these equations, I'm going to split them at the equal sign, and then I'm going to look for my variable. Here my variable is x. I have 4 times x. The opposite of multiplying by 4, well, I want to get rid of that 4. The opposite of multiplying would be to divide by 4. So cancels out here. 32 divided by 4, I'm left with 8. So I want to check my answer. So I plug that 8 back into the original problem, which was 4 times x. I'm putting 8 in for x. 4 times 8, I can check it on my calculator, is 32. So they're both equal on both sides. They check out. Here I've got 12 times q equals 60. So q is my variable I'm solving for. I have a times 12. The opposite of times 12, divide by 12. I have to do it on both sides. Cancels out here, and I get q equals 5. Now I'm going to check it by plugging it back in. So 12 times 5 equals 60. 12 times 5 is 60. Both sides are equal. My answer checks out. It's a quick and easy way to check my answers and make sure that I didn't make any mistakes when I was solving my equation. All right, so let's look at some two-step equations here. So in this first one, I have 14 equals 2 times y divided by 5. So just like all the other equations I've done, I'll start by splitting it at the equal sign. To get rid of this divide by 5, I'm going to have to multiply by 5. And I'll do that on both sides. So I'm going to do that step first and just get that step kind of out of the way. So I'll be left here with the 2y because I haven't canceled out the 2 yet. And 14 times 5 is going to give me 70. Okay? So now I have to get rid of the 2y. This is multiplying by 2. So I will divide both sides by 2. And I get 35 equals y. Okay? So now I'm going to check my answer. In order to check my answer, I'm going to plug 35 in for y. So 2 times 35 is 70. 70 divided by 5 is 14. So both sides have an answer of 14. It checks out. All right, let's try one more like this. Split it at the equal sign. I'm going to get rid of this divide by 2 by multiplying by 2. Cancels out here, and I'm left with 3z, and 9 times 2 is 18. Now to get rid of the 3, since it's 3 times z, I'm going to divide by 3. I'm always doing the opposite, and I get z equals 6. And now I'm going to check my answer. So the original problem said 3 times z divided by 2. So I'm going to do 3 times 6 divided by 2. I want an answer of 9. So 3 times 6 gives me 18. 18 divided by 2 gives me 9. Both sides check out. I know my answer is correct. All right, last problem. So in this last problem, we're going to look at a real-life application. Here we have a parallelogram-shaped courtyard with an area of 2,730 feet square. So here's the courtyard. It has a sidewalk going across the parallelogram there. That sidewalk also represents the height of the parallelogram, because if I flip this parallelogram on its side and that was the base, the sidewalk would kind of represent the height. And we want to know the length of that sidewalk. Well, with a parallelogram, I know that to find the area, I can do the base times the height. So the area has been given to me, 2,730. The base here is 65. And the height, which is also the length of that sidewalk, is what I'm actually looking for as my answer. So I'm going to have to solve this by solving for h. So I'm going to split my problem at the equal sign. I have times 65. The opposite would be divide by 65. And I'm going to do that to both sides. Here it will cancel out. 2,730 divided by 65 leaves me with 42. And over here I have h. So the length of the sidewalk there would be 42 feet.